So you're saying I can ask this cat any question?
The cat is connected to the computer. You just type in the question, it will read his mind. There the answer comes.
You're the man! I've been looking for this for weeks.
A polynomial function of degree 3, p of x, has a root or 0 of multiplicity 2 at x equals 5, and a root or 0 of multiplicity 1 at x equals negative 3. The graph of p of x contains the point 0, negative 37.5. Find p of x. Whenever we are given the roots or zeros of a polynomial function, we are also given binomial factors of the polynomial function, where if a polynomial function has roots or zeros of r sub 1, r sub 2, r sub 3, and so on, then the polynomial function can be written in the form as shown here, where a is a constant, and notice each binomial factor is in the form of x minus the root or 0. And because we have a degree 3 polynomial function, we will have 3 binomial factors. Our polynomial function will be in the form p of x equals a times the quantity x minus r sub 1 times the quantity x minus r sub 2 times the quantity x minus r sub 3. And now looking at the given information, we are told the polynomial function has a root or 0 of multiplicity 2 at x equals 5, which means x equals 5 is a double zero or double root of the polynomial function, which means 2r values will be positive 5. Let's let r sub 1 equal 5 and r sub 2 equal 5. And then we have a root or 0 of multiplicity 1 at x equals negative 3, which means this is a single root or single zero, and therefore r sub 3 is equal to negative 3. Performing substitution gives us p of x equals a times the quantity x minus 5 times the quantity x minus 5 again. Notice because x equals 5 has multiplicity 2, we have two factors of x minus 5, and then because the root or 0 of x equals negative 3 has multiplicity 1, we have one factor of x minus negative 3. Let's simplify x minus negative 3 to x plus 3. Let's also write this as the quantity x minus 5 squared. So we know p of x is equal to a times the quantity x minus 5 squared times x plus 3. Now we need to find the value of a using the given point, which is a vertical or y-intercept. Because we are given the point 0, negative 37.5, we know that p of 0 must equal negative 37.5. Using this information, we now substitute 0 for x and negative 37.5 for the function value here. This will allow us to find the value of a. Performing the substitution gives us negative 37.5 is equal to a times the quantity 0 minus 5 squared times the quantity 0 plus 3. Simplifying, we have negative 37.5 equals a times the square of negative 5, which is 25, times 3. So we have negative 37.5 equals 75a. To solve for a, we divide both sides by 75. Simplifying on the right, we have a. A is equal to this quotient here, and negative 37.5 divided by 75 is equal to negative 0.5, or if we want, negative 1/2. Of course, if we needed to, we could check this on the calculator, which I've done here. Now that we know the value of a, we can write the polynomial function that satisfies all of the given conditions. The polynomial function that satisfies all of the given conditions is p of x equals a, which we now know is negative 1/2 or negative 0.5 times the quantity x minus 5 squared times the quantity x plus 3. I hope you found this helpful.